Okay, I'm hoping everyone had a nice break, and I'm still on my cruise, so I'm recording this so that you can still do 4.7. And what's nice about 4.7, there's nothing new here. We dealt with transformations from the beginning. From chapter 1, we talked about stretches, shrinks, up, down, left, right movements. The same thing's going to happen in chapter 4, okay, with these polynomial functions. So I start off with the cubic function. So I just want us to graph x cubed. Okay, so since it's odd, we know it's going to point in opposite directions, and this is the most basic polynomial function we can have. So you plugged in a 0, you get a 0. So this graph, and you could use a calculator, but I'm not going to use a calculator for this. When you plug in a 1, you get a 1. If you plugged in a -1, you get -1. So -1 times -1 times -1 is the outcome of -1. So if you only plotted those points, you would think it's a straight line, but it's not, because as soon as you plug in a 2, 2 cubed is all the way up at 8, because 2 times 2 times 2 is 8. And then if you plugged in a -2, you would be all the way down at -8. So this is the general shape of a cubic function. Okay, so all we're going to do is transform this. I'm going to tell you which directions to move it. We can stretch it, shrink it. So that's this next section right here, where if I want to move a cubic function down to, we'll call this g of x. So write an equation of a cubic function. So again, as soon as you see cubic function, know it's the third power, and the most basic is just down, so we just do a -2. Okay, just as easy as an up, that's just plus. So g of x, and it's a 3, not a 2. So x cubed plus 6 is going to shift that graph up 6. And remember, you can always confirm this on a calculator, especially these left and right movements. Okay, a lot of students get confused with left and right movements. So for a left, you're going to add to the input. Okay, so we need parentheses around the x, and you're going to do plus 5 cubed. Okay, so now I'm going to confirm this on a calculator. So just so that you can understand it, this was a test or quiz. Left movement, we have to take our input, add 5 to it, then we're going to raise it to the third power. So this graph should be to the left, and it is. From the origin, 1, 2, 3, 4, 5. Okay, nothing else changes with that graph. It's pointing down on the left, pointing up on the right. Okay, if I want to go to the right, that's where we subtract to our input. So need parentheses, and we raise it to the third power. Okay, so we can do 2 movements. So if I need to go to the right, it's going to be x minus 7, and then we're going to shift up. And again, very easy to show that on a calculator. Okay, so then this next one, left. So when we go to the left, kind of have to think backwards. Left is plus 8, and then down is minus 10, but on the outside of your function. Okay, so we know this is a shrink because it's less than 1. So I put that number out front. So I would have a 1/3 in front. And since I'm going to the left, I need to go and use parentheses around the x. And to the left is going to be plus 1, and it's to the third power. Okay? Where here we know it's a stretch because it's a value greater than 1. So the second you see a number in front greater than 1, you know you're stretching it out. So it's just 7/2 x cubed. And since it's down, I can do it after the cube. I put a -9. Okay? So then our reflection. So we're going to reflect over the x-axis, and then we're going to move right 12 units and down. So a reflection, and we're doing this first. This would be different if the reflection was last, but since we're doing it first, I just make it a negative out front. Okay? Since it's to the right, I must put parentheses around the x, and I must subtract 12, and then we're going to move it down. Okay? Now the end behaviors are going to be switched, because the reflection now is the graph's going to point up on the left, down on the right. okay? And then this one, we're doing a vertical stretch with a factor of 5, and then reflected over the x-axis. That's real easy. We just put a -5 in front of the x cubed, okay? And then the last one on this page, since it's a shrink, we know this value has to be less than 1, and it is. It's 0.25 or 1/4. So I put the 0.25 in front, and then since we're going to the left, I'm going to add 7, and we're going to go up, so it's +3. Okay, so again, that should come back to you from the beginning, from chapter 1. We did it with chapter 2 then with quadratics. It's going to be a theme. Every time we learn new functions, you need to understand these transformations. So there's our first page of notes. This next page in our notes, we should quickly be able to sketch a graph of, in this case, a cubic function. Now, you can use a calculator to verify this, but for this, I really don't want to rely on a calculator. We should be able to look at the rule and understand what's happening to the graph. So the second I see this rule, I know I'm going to shift to the left 2. So I'm moving left 2 and down 5. Okay, so instead of being the cubic function at the origin, passing through the origin, we are now going to go 2 units to the left and down 1, 2, 3, 4, 5. Nothing else about that cubic function changes. So we know, again, you can easily confirm this on a calculator, but if I plugged in a 0, I have 2 cubed, because 0 plus 2 is 2. 2 cubed is 8. 8 minus 5 is going to be a 3. So I'm going to plot 0, 3. That gives me enough to understand what's happening on the right of my graph, and then it's going to point down forever. Okay, so that's all we did. We took our cubic function x cubed, we shifted it to the left 2 and down 5. Okay, for this one, it is going to be a reflection, so make sure you understand that that is a reflection about the x-axis. It's going to be to the right 6 and up 1. Okay, so let's go to the right 6 and up 1. Now, this time is going to be the opposite of this. So if you plugged in a 5, you're going to end up with an outcome of 2. Okay, so if you did 5 minus 6, you have to follow order of operations, which is -1. -1 cubed is -1, but then it becomes the opposite of -1, which is 1. 1 plus 1 is 2. Okay, if you plugged in a 7, you're going to get a 0, and I'll do an 8 yet, because if you did an 8, you're going to end up with 2 inside the parentheses. 2 cubed is going to be 8, but it's going to be a -8, plus 7 is -7. Okay, so I have that dot just to help me understand what's happening to this graph. Okay, and like I said, you could type this into a calculator just to confirm. So just a reminder, negative, so make sure it's the negative button, and then x minus 6, and then I'm going to raise it to the 3rd power, and then I'm going to add 1. So when I hit graph, I expect it over here pointing up on the left, pointing down on the right. And again, you have your table that you can go and see lots of different points. We don't have to scroll all the way over here to be able to plot some points like 5, 2, which we already had, 5, 2, and then there's our 7, 0. There's our 8, -7. Okay, so again, these can be checked on a calculator, but I'm hoping that you're getting a sense of what's happening right away. This one's real easy. Just one movement, and it's going to be to the left 4, okay? Because if I plugged in a -4, I get an outcome of 0, okay? But then everything else about this function, the size of it, stays the same if you plugged in a -2. -2 plus 4 is 2, but then when you cube it, you're all the way up here at 8. Same thing's going to happen, but it's going to be -8 when you plug in a -6. So there's my dots, and that's what's happening to that graph, okay? And this last one, all you have to realize is it's up 3, and it's a reflection. So it's a reflection which changes the end behavior. So how it ties to end behavior, I now know it's going up on the left and it's going down on the right. Okay? So this last section, we should instantly be able to look how we're transforming, and it doesn't have to be cubic, it could be any power. So if I gave you an x to the fourth, a quartic function, you have to know that, hey, there's a number in front greater than 1. It's a vertical stretch. Okay? And then that +3 tells you you're shifting your graph up 3. Okay? Here, since it's inside and we're subtracting, it's going to be right 2, and the +1 is up 1. Okay? Here, there's actually 3 movements, 3 transformations. It is a reflection. Like I said, we only do of the x-axis, so you just need to say reflection. I'm going to write of the x-axis. The 4 is a vertical stretch. And finally, the -7 is down 7. Okay? And this last one, it's going to be to the left 9 and down 2. Okay? So hopefully you understand these notes. Again, nothing new as far as the transformations from the very beginning, but this should allow you to get your big ideas 4.7 done. And then I'm also going to assign that where you can get started on the practice exam. Okay, so when I get back, we are going to do 4.8, which is characteristics of a polynomial function, but you can hold off of that problem on the practice. So the 2 days I'm going, we should get these notes, do big ideas 4.7, and start the practice exam. Okay, thanks for watching. Hopefully these notes make sense. Take care.